Okay. All right. So we are asked to find the 90% confidence interval for the population variance here. So what we are going to do here is to look at the way that we construct the confidence interval estimates. The first thing is we need to check the assumptions. So we know that the population of length of the steel shops is normally distributed, is given in the questions. And we have a simple random samples here. So both assumptions are satisfying here. Okay. You see, first assumption, second assumption. So both assumptions are satisfying. So after you said that, okay, the assumption are satisfying, we can now find the confidence interval estimate by applying the formula, okay, for lower confidence limits and upper confidence limits. Okay. Now, the lower confidence limit is equal to n minus 1, s squared, chi squared, and 4 over 2. Okay. So n here is our sample size. Our sample size here is 10. So it will be equal to 10 minus 1. The value of s squared here, or the sample variance here, you have to calculate it yourself using the formula given in our first lectures. Okay. And then we have to look up for the chi-square value and for over 2. So look up for the value of chi-square. We have 90% confidence interval. So 1 minus n4 here must be equal to 0.9, 90%. So from here, we say that n4 here is equal to 0.1 and n4 over 2 is equal to 0.05. So here we have to find chi-square of 0.05. And the degrees of freedom here is 10 minus 1. So this would be equal to 9. Okay. And then we have to find the value of s squared here. Right. So let's see how can we do this. I think that this is given in your line. Yeah. Sorry, this is just there is something missing here in my system. So we have chi-square. Here. So from the calculation, we have this one here. And then we have So chi-square 0.059 here is equal to 16.9. Chi-square 0.959 here is 3. And then all we need to do here is to apply the formula. And then we have the lower confidence limit here and the upper confidence limit here. Okay. And then we have to make the conclusion here. We say that the 90% confidence interval estimate of the population variance of the length of the shops is. And then we put the lower confidence limit here and the upper confidence limit here. Okay. So it's all about applying the formula here, checking the assumption, applying the formula to calculate the confidence interval, and then making the conclusions. Okay. And I think that the solution is given in your slides, so you can just read it for yourself. Okay. Now we have another examples here. And this example here is also given in your news slide. And I'm going to introduce you, the full solution for this. Okay. So in step 1, we are going to check the assumption. The assumption here is the weights are normally distributed. The first assumption. The second assumption is samples. So we have simple random sample. And the first one here is the weights are normally distributed. Okay. So we have two assumptions here. In this next step here, we have to find a lower confidence limit and upper confidence limit. N minus 1, S squared, chi-squared, N4/2, N minus 1, S squared, chi-squared, 1 minus N4/2. So we are going to wait for one here. So N here is equal to 41. The sample standard deviation is 0.05. So this one here should be S equal to 0.05, the sample standard deviation. Okay. And we have 90% here. So it means that 1 minus N4 is 0.9. N4 is 0.1. And N4/2 here is 0.05. Okay. So all of the information is given. So for this, we are going to find 40 because 41 minus 1. Multiply with now 0.05 squared divided by these values here. Again, we have 40.05 squared divided by this. Okay. So, okay, next thing is we have to find the chi-square N4/2 here. The degrees of freedom here is equal to N minus 1 and is equal to 40. So we are going to look up the table for 40. Chi-square N4/2 is 0.05. So we have chi-square 0.05 here, 40. And 1 minus N4/2 here is chi-square 0.95, 40. Okay. So all you need to do here is to look up the table. Here. Just come back to our tables here. We look for the degrees of freedom equal to 40. Okay. And the N4 is 0.05 here. So it should be 55.758. So 55.748 40 0.05 squared. And here 0.95 here 0.95 26.509. This one is 5. And then you calculate it. And then you calculate these two values here. Okay. And if you look it up you can just calculate it for yourself. Okay. So I just present the one going to find the confidence interval estimate here. Okay. Check the assumption. And if all the assumptions are satisfied, then we construct the confidence limit, both lower and upper for the intervals. We calculate this one. And then we find it here to be equal to this. It's square. Not sure whether it's square here, but you have to check it again. Sorry. Okay. So, But here, they ask you to find the confidence interval estimate for the population standard deviation. So can you find the two values here, plus, and send me to me via the chat box, so that I know? Calculate the two values here. Maybe I have to zoom it in a little bit. Yeah. Lower confidence limit and upper confidence limit, and tell me. Okay, so we have 0.0018 and we have 0.0037 or 38. Okay, right. So if we calculate this, it asks you to find the standard deviation, the confidence interval estimate for your standard deviation instead of the variance. So the variance will be between 0.0018, 0.0038. But then it asks you for the confidence interval estimate for sigma, but not for sigma square here. So all you need to do is to take the square root of this. And then you just have this one here. Here I have standard deviation. Okay. Right. So pay attention to the questions, okay? If it asks you for the variance, then you just do just what I say here. But if it asks you about the confidence interval for the standard deviation, then you have to take the square root of everything, okay? All right, so that is the first case when we have to construct the confidence interval estimate. The next case here is when we have the hypothesis test here. And I'll just summarize the step for the hypothesis test here. For other things, you can just read it on the slide. So the hypothesis test. Okay. Now for the hypothesis test, we can just follow the 6 steps that we know. Okay, so the first one here is hypothesis. So we have HO, we have HA. HO here is when we have sigma square equal to some values. Sigma square different, smaller than something. Sigma square small greater than, and sigma square different from something. And as for HO is always the same, equal. Okay. Now the second step here is when we have the test statistic. In order to specify the test statistic here, we have to check the assumption. Now the assumption for this will be the same as for confidence interval. Okay, so the population must be normally distributed, and the we have random sample. Okay. After we check the assumption, then we have the test statistic here. Chi-square equal to n minus 1 s squared divided by sigma square with df equal to n minus 1. Step number 3 is when you specify the level of significance. Step number 4 is what we call the decision rule. Decision rule will be different for the p-value approach. Normally, when we run the code in R will return you with a p-value. So for the p-value approach here, we will reject HO if p-value smaller than n. Okay. And for the case that we use a critical value approach, then it will depends on the test that we have. Let's say that we have A here, we have B here, and we have C here. So if we have the case of 1A, then we will reject HO if the value of chi-square smaller than the chi-square or 1 minus n for 1b, we will reject the non-hypothesis if the value of chi-square greater than the value of chi-square n for. And for the case that we have two-tailed test, we will reject HO if the value of chi-square smaller than chi-square 1 minus n4/2 or chi-square greater than n4/2. Okay. Now, why do we have this? It is because if we draw a graph here, a chi-square here. Then if we have the left tail test, then the rejection area will be to the left here. And it should be equal to n4. So this value here is chi-square 1 minus n4, because the area here is 1 minus n4. And this one here is the rejection areas, and is equal to n4. So if the chi-square value is smaller than chi-square 1 minus n4, then we will just reject HO. Okay. Similarly, for the second case here, if we have the graph of chi-square like this, because we have the right tail test here, so the area of the rejection here will be to the right rejection area, n4. So this value here is chi-square n4. So that's why we reject it here. Okay. And as for the last case here, we have the two tail test. So the rejection areas here will be tails of the distribution. And each of these areas here will be 2 over n4 over 2 here. So this areas here is chi-square n4 over 2. And this one here is chi-square 1 minus n4 over 2. Okay. All right. So that's the reason why we have the rejection areas like this. And after we apply the decision rule here, depending on the questions, then we need to calculate the value of the test statistic. And we will find the value of chi-square, and we will compare it with the critical values or the p-values. And then for the last step here, we make the conclusion. Remember that in the conclusion, we either reject HO or we do not reject HO. If we reject HO, it means that there is enough evidence that the alternative hypothesis is true. And if we cannot reject HO, it means it's not enough evidence. Okay. So this is these are all the steps for the hypothesis testing here for the population variance. Okay. All right. So you can see it here, the whole step here. So if we look again at our slide, and we have to past this. And this is one examples here. Okay. Here are the examples. Okay, you can just read the examples here at home. But we can do one exercise here together. That is the exercise from your textbook. Okay. And this can be our last slide. Okay. Sorry for keeping you that long, but because we start quite late. So that's why we have to overrun other classes here. Okay. So now, for example, we have the variance here. At the end of 2008, the variance of the government bond was these values here. Now, we have to use n4 equal to 0.05 to conduct the hypothesis test whether the sample data indicate that the variance here has changed. So if you look at the here, it asks us to conduct the hypothesis test the variance has changed. So it means that we will have to find HI here, variance different. So change. Originally it was thought to be equal to 7. So we'll just write 0.7 here. And the non-hypothesis should be sigma squared equal to 0.7. Okay, so this is how we write the hypothesis. We read the questions, and the question should give us the alternative hypothesis as well the non-hypothesis. We'll just replace with the equality sign here. Okay. And from the problems here, we calculate the value of S squared here to be equal to 0.69. The sample is 12 and N for here is 0.05. Okay. So this is the solution to the exercise. We formulate the hypothesis test. We check the assumption. Now we need to check the assumption here in the second step. Okay. Here. Before we specify this. The rejection area is because we have two tail tests here. So the rejection area is, we will reject HO if chi-square greater than and chi-square greater than chi-square n4/2 or chi-square smaller than chi-square 1 minus n4/2. So chi-square n4/2 is 0.025 because we have n4 here equal to 0.05. And this one here is chi-square 0.925. So that's why you have 9.5. That's why we have this value here. Okay. And the value of the test statistic here is equal to n minus 1 s squared sigma squared, and is equal to 11 0.69 divided by 0.7. Okay, and then you have these values here. And when you compare the values of x chi-square here equal to 10.8 with the value of 21 and 3 here, you will easily see that chi-square here is smaller than 21, but it's greater than 3. So we do not reject HO because it did not fall into the rejection areas. And then we conclude that, there is not enough evidence to say that the variance in the bond yield has changed. Okay, so we always decide to reject or not to reject the non-hypothesis, but we always make the conclusion about the alternative hypothesis. Okay. All right. So this is how we do the test here. We still have one more examples. This is the summary, but I think that it is quite difficult to see here. Okay. We still have one examples here, but then I think that I have taken up a lot of time from you already. Okay, so we are going to here, and before we stop, I just want to summarize everything that we study for this session here. Okay, before you ask any question. Okay, so here in this session we study the inferences about the population variance, and normally we don't have variability here. So we have to test, or we have to make sure that the population variance is in the acceptable range. Because we have no idea about the population variance, we use the sample variance to estimate the population variances. In order to make the inferences about the population variance, we have to talk about the distribution or the graph of the data. And for this, we are using chi-square distribution. Okay, the condition for the chi-square distribution here is the population is normally distributed. There are some characteristics of the chi-square distribution here and how we note the values here. As for the inferences of the population variance, we can either have the confidence interval estimates. We follow the step like checking the assumption, finding the confidence interval, and making the conclusions. We also have the hypothesis test here, okay, in which we specify the hypothesis, the test statistic. The decision rule is the most important step here because we have two kinds of decision rule. The first one is for the p-value approach, and the second one is for the critical value approach. Okay. For the p-value approach, the decision rule is the same. And as for the critical value approach, then we have to depend on the hypothesis that we specify. Left tail test, right tail test, two tail test. Okay. Okay. Questions? Questions?
Sorry, teacher, but I think it takes a lot of time to calculate this stuff. Can you have some method to speed up?
Calculate what?
I mean, the data here, it takes a lot of time to calculate it. Do you have a better method for calculate it?
You can just put all the data into Excel file and then you run it. Okay. If you are doing it online, but if you are doing it offline on papers, you may be given the values. Otherwise, you have to calculate it manually. Or some of the questions in the textbook do give you the Excel file, so you can just ask Excel to do it for you. You can just calculate it in R. Remember that we can calculate the standard deviation in R. We can calculate the variance in R. So just type the values in R, and then you ask R to calculate it for you. Okay. Okay. If you don't have any questions, then just leave the room. I know that I have taken you quite a lot. Okay. And if you don't have any, then we are going to stop here. Okay. Thank you, class. And if you have any comments, please leave the comments for me so that I know to fix the links for the next class. Okay.
Goodbye, teacher.
Hi, thank you. Bye-bye.